All right, AP Environmental. I just want to continue here with part two of our video on photochemical smog. And right now, I'd just like to kind of take a look at this diagram, just kind of review a little bit, kind of the big picture of photochemical smog. So, in the previous video, we talked about um, NO2. NO2 being produced by automobile emissions, amongst other things. I mean, like factory emissions can produce it as well. But again, in the United States and in most of the developing world, or so I should say the developed world, auto emissions are the big culprit when it comes to NO2. And that NO2, again, once it's in the air, it'll naturally break down and form NO. So these are kind of your primary pollutants, as well as VOX, right? VOX are chemicals that um, things like paint and gasoline and I think I called them smelly chemicals in the previous lecture video. But those things, again, anthropogenically can go up into the air through a variety of reasons. So again, these things, once they're in the air, they tend to react with each other to produce these secondary pollutants. One of them is ozone. Again, this is tropospheric ozone, the stuff that lingers close to the surface, which is not very good for our health. And the other one are those PANs. Those perioxyl nitrates that again are not a good thing to be exposed to. So these secondary pollutants again are produced from these primary pollutants. All right, now another thing that could occur when all of this pollution enters the atmosphere, especially above a large urban area, is something called a thermal inversion. These thermal inversions occur, anytime you get a lot of pollution, coming up from, again, usually an urban area. This picture here is a good example. But what I want you to look at here closely is the left-hand side. This is temperature. So we know that as we go up in the troposphere, temperature gets colder, right, with altitude. So this is sort of the temperature gradient here. We're going up and up and up. We're getting cooler and cooler and cooler. It'll be really cold at the top of the troposphere. The surface down here is generally warm, especially in the summertime, right? This will be really warm down here. But again, you get all of this pollution that's produced, from these urban areas. And eventually what can happen is you can get this inversion layer, which is basically a warm kind of a pocket of air that exists in between these two colder regions. So whenever this happens, we call this a thermal inversion. And I guess probably the biggest issue with it is that this ends up trapping a lot of pollution underneath it. So the pollution can't really escape. So you get this, layer above these urban areas that ends up trapping all of this pollution underneath it. And that can be anything from, ozone to, PANs or anything else that might be being produced near those urban areas. So this picture here, you can almost see the inversion layer, right? I mean, you can almost see like the blue sky above, that's above the inversion layer, and the kind of the brown air below it, that would represent all the pollution, and the inversion would kind of be like right in here. This inversion layer would be kind of right in this general area. So I mean, like in this type of picture, you can definitely see that exists. And again, it's mainly because there's so many people in this area producing so much pollution that it creates that thermal inversion. All right, so some ways that we can maybe prevent some of this stuff from happening. Smog reduction. Photochemical smog it's not only a big problem in our country, but it's a big problem pretty much around the world in any developed country. This is an interesting thing here. It says, according to the EPA, the Environmental Protection Agency, over half of our country is breathing excessive levels of smog. So that means the air quality where you live, and I'll be honest, in Northwest Indiana, because we're so close to Chicago, our air is not that healthy. We get a lot of that residual effect of all that air pollution from that large urban setting that just kind of lingers over to us. So it's kind of an issue, and we don't even know about it. But if we're going to really stop it from happening, especially smog, I guess the biggest thing is we have to just, limit or find some way to produce less of those primary pollutants, right? NOx compounds and VOx. I mean, I guess with NOx, I mean, what are you gonna do? Tell people to not drive cars? Well, I mean, it could be something as simple as taking more public transportation. We've talked about that before. We've talked about electric cars or hybrid vehicles maybe being some option down the road for some people. Riding a bike instead of driving somewhere. That would be a way that we could produce less of these NOx compounds, NO2 especially. Vox, I mean, there might be some simple things that we can do. I mean, they sell, for example, these no spill spouts on gas tanks. So you're going to fill your lawnmower up, for example, in the summertime, instead of spilling it all over your garage. We have these little things that'll help us with that. Putting lids on paint cans. When you're done using them, don't let them sit in your garage without a lid on it. Because again, those contain volatile organics. The gas pump itself, over the years has been engineered. There's a lot of science that actually goes in to the engineering of a gas pump, so that these things don't leak gasoline, they don't spill them all over the place. Because again, gasoline is a volatile organic. So there are some things that we can do to help reduce some of these emissions. This is probably one of the bigger things that we've done. This is called a catalytic converter. And this is a component that is pretty much on every single vehicle that runs in the entire world. In fact, in 1975, every single car manufacturer had to create vehicles that were required to have these catalytic converters underneath the vehicle. And just kind of explain to you briefly how this works. There's two ends to it, right? There's an end over here. There's an end here. Well, this end here is basically connected to your car engine. So when your car is burning gasoline, all those emissions are going to pass into this converter. And then on the other side is what's going to pass through the basically through the other pipe. So think about what's coming in to this catalytic converter, right? Whenever we burn gasoline, which is a product of a fossil fuel, you're going to get NOx, which is not good for the air, right? That's a really bad one. That's going to contribute to photochemical smog. You're going to get carbon monoxide gas, which we talked about last week is bad, and you're going to get other hydrocarbons. These hydrocarbons, again, things like methane and things like that could be considered greenhouse gases. So these are all things that are not good, that are produced by our car engines. So those things are going to pass through. Now, inside of the converter, I'm not going to get into the chemistry of this too much, but there's a catalyst inside. It's usually made of things like palladium or platinum, possibly. But that catalyst on the inside, basically there's chemical reactions that take place that convert these bad compounds into these things. So let's take a look at what we have here. So in one end of the pipe comes the bad stuff, and out the other end comes things like nitrogen gas, which we already have an abundance of in our atmosphere. In fact, living things need nitrogen, so that's not really a terrible thing. Water, that's not going to hurt anybody. That's water vapor, steam. And now this one here, CO2. Now, even though CO2 is bad, it is a greenhouse gas, and let's be honest, we don't want that stuff building up in our atmosphere. But what's the other choice? A bunch of NOx compounds, a bunch of carbon monoxide, more hydrocarbons. I mean, do we want to put these into the atmosphere, or do we want to put these into the atmosphere? I suppose this is sort of the lesser of two evils, compared to these. So I call these less bad compared to bad. Um, but I mean, this has done quite a bit for our air quality in the United States. I mean, they're not 100% efficient. They're not perfect. There is still some harmful products being produced, like CO2, but compared to the alternative, it's probably a little bit better. Now, one thing also about catalytic converters, um, leaded gasoline. We talked about that last week. Leaded gasoline will actually inhibit the catalyst from working inside the converter. So this is another reason why we don't put lead in our gas, other than the fact that lead is toxic and we don't want to breathe in fumes that have lead in them. But lead will actually destroy the converter. So we use unleaded gasoline. Again, there's another reason why we do that. So again, catalytic converters, understand what they are and kind of what they do, because again, they have really helped to improve air quality in our country and also around the world. It's kind of a nice innovation that we've come up with. All right, guys, that is it for the notes for these particular topics. Have a good day. I will see you soon.